Our lesson for today is all about similarity of figures. In the previous lesson, you were able to be more acquainted with ratio and proportion, which is very essential in learning our new lesson. Now, in this module or in this lesson, we will focus on the similarity of figures. As you study it, you are encouraged to answer the following question. First, how can we say that two given polygons are similar to each other? And second, how scale factor is related to other dimensions of similar polygons? In addition, this lesson will help you solve problems related to similarity of figures. Now, let's have a review. Again, ratio is used to compare two or more quantities, while the proportion is the equality of two ratios. In symbols, we have A over B is equal to C over D, or A is to B is equal to C is to D. Each number in a proportion is called a term. In the proportion A is to B is equal to C is to D, the terms A and D are called the extremes, while B and C are called the means. And according to the fundamental rule of proportion, in a proportion, the product of the means is equal to the product of the extremes. Now, for this activity, I will give you 1 minute to answer the following proportions by applying the fundamental rule of proportion. Time's up. Now, let's check your work. For number 1, we have 5 over 9 is equal to 10 over m. So now, we're going to apply the fundamental rule of proportion. So 5 times m is equal to 9 times 10. So we have 5 times m is 5m is equal to 9 times 10 is 90. And after that, let's apply the division property of equality. So let's divide both sides by 5. So 5m divided by 5 is equal to m. And 90 divided by 5 is equal to 18. So the answer in number 1 is 18. Next, for number 2, we have 10 over 6 is equal to s over 3. So let's multiply 10 times 3 is equal to 6 times s. So we have 30 is equal to 6s. Again, let's apply the division property of equality. Let's divide both sides by 6. So 6s divided by 6 is s, and 30 divided by 6 is 5. So the answer for number 2 is 5 is equal, or s is equal to 5. For number 3, we have 4 over 9 is equal to 8 over 2r. Let's multiply 4 times 2r is equal to 9 times 8. So 4 times 2r is 8r, and 9 times 8 is equal to 72. Again, let's divide both sides by 8. So 8r divided by 8 is 1r or r. And 72 divided by 8 is equal to 9. So therefore, the answer in number 3 is r is equal to 9. Next, for number 4, we have b minus 6 over 8 is equal to 8 over 2. Let's multiply b minus 6 times 2 and 8 times 8. So we will have b minus 6 times 2. We have now 2b minus 12, and 8 times 8 is equal to 64. And after this, combine similar terms. So we're going to transpose negative 12 to the right side, and it will become now positive 12. So it will become 2b is equal to 64 plus 12. So bring down 2b, and 64 plus 12 is equal to 76. Let's apply the division property of equality by dividing both sides by 2. 2b divided by 2 is equal to 1b or b, and 76 divided by 2 is equal to 38. So the answer for number 4 is 38. Now for number 5, we have n plus 5 over 7 is equal to 8 over 6. Let's multiply n plus 5 times 6 is equal to 7 times 8. So n plus 5 times 6, we have 6n plus 30 is equal to 7 times 8, we have 56. Again, let's combine similar terms. So we transpose positive 30 to the right side, and from positive, it will become negative 30. So we have now 6n is equal to 56 minus 30. So 56 minus 30, we have 26. Next, let's divide both, let's apply the division property of equality. So let's divide both sides by 6. So 6n divided by 6 is 1n over n, and 26 over 6. We need to find the lowest term, and the lowest term is 13 over 3. So therefore, the answer in number 5 is 13 over 3. Now, let's proceed to our next slide. Quadrilateral QRST corresponds to quadrilateral JKLM. Each side of quadrilateral QRST is k times the corresponding side of quadrilateral JKLM. Take an intensive observation on their shapes, sizes, and their corresponding angles. So for our guide question, first, what do you observe about the shape of the two quadrilaterals? Second, what can you say about the lengths of their sides? And third, what do you notice about their corresponding angles? To know the relationships that exist between the pair of polygons on the slide, let us study similarity of figures. So what is similarity all about? Two polygons are similar if their vertices can be paired so that corresponding angles are congruent and corresponding sides are proportional. Similar polygons have the same shape but different sizes. To denote similarity of polygons, the symbol, like a wave, which is read as similar to, is used. Next, in the figure on the slide, parallelogram EFGH is similar to parallelogram PQRS. The corresponding angles of quadrilaterals EFGH and PQRS are angle E and angle P, angle F and angle Q, angle G and angle R, and angle H and angle S. Notice that the degree measure of angle E is equal to the degree measure of angle P, which is 105 degrees. Therefore, angle E is congruent to angle P. Next, the degree measure of angle G is equal to the degree measure of angle R, which is 90 degrees. Therefore, angle G is congruent to angle R. Next, the degree measure of angle F is equal to the degree measure of angle Q, which is 45 degrees. Therefore, angle F is congruent to angle Q. And for our last, the degree measure of angle H is equal to the degree measure of angle S, which is 120 degrees. Therefore, angle H is congruent to angle S. Since quadrilateral EFGH is similar to quadrilateral PQRS, the corresponding sides are proportional. Moreover, the scale factors or the ratios of the corresponding sides are equal. Now, let's identify the scale factors or the scale factor of the given two quadrilaterals. So for our first corresponding sides, let's get EF or line segment EF and line segment PQ. To find the ratio of corresponding side, we will have EF over PQ, and let's substitute the value we have is equal to 11 over 33, and the lowest term is 1/3. Next, corresponding side, let's get line segment FG and line segment QR. So to find the ratio of corresponding side, we will have FG over QR and substitute the value we have now 15 over 45. And the lowest term also is 1/3. For our third corresponding sides, let's get line segment GH and line segment RS. To find the ratio of corresponding side, we have GH over RS. And let's substitute the value. We have 4 over 12. And the lowest term again is also 1/3. And for our last corresponding sides, we have line segment HE and line segment SP. So to find the ratio of the corresponding side, we have line segment HE over line segment SP. And let's substitute the value. We have 8 over 24. And also the lowest term is 1/3. Now, in writing similarity statement, make sure that the corresponding angles of the polygons are written in the same order. The similarity statement can also be based on the correspondence of the sides of the polygons. In the previous example, the similarity statement parallelogram EFGH is similar to parallelogram PQRS indicates that angle E is congruent to angle P, angle F is congruent to angle Q, angle G is congruent to angle R, and angle H is congruent to angle S. In addition, this statement signifies that line segment EF and line segment PQ, line segment FG and line segment QR, line segment GH and line segment RS and line segment EH and line segment PS are the corresponding sides of the quadrilaterals. Now, let's have an example. For our first example, in the figure on the slide, triangle ABC corresponds to triangle DEF. So let's answer the following question. For number 1, or for the first question, identify the corresponding angles of the triangles. So the corresponding angles are: angle A is congruent to angle D. Angle B is congruent to angle E. And last, angle C is congruent to angle F. For our next question, determine the corresponding sides of the triangles and the scale factors of the corresponding sides. The answer for the corresponding sides are line segment AC, and line segment DF. To get the scale factors, we substitute the value. We have 14 over 28, and the lowest term is 1/2. Next corresponding sides is AB over DE. So if we substitute the value, we have 6 over 12. And the lowest term is also 1/2. And for our last corresponding side, which is line segment BC and line segment EF, so to find the ratio of corresponding side, we have BC over EF and substitute the value. We have 10 over 20, and the lowest term is 1/2. Since the ratios of the corresponding sides are equal, then the corresponding sides are proportional. So for our third question, are the two triangles similar to each other? Why or why not? If so, write a similarity statement and determine the scale factor. So for number 3, the two triangles are similar because the corresponding angles are congruent and corresponding sides are proportional. The similarity statement is triangle ABC is similar to triangle DEF, and the scale factor is 1/2. For our second example, the given is triangle EFG is similar to triangle MNP. So let's solve for the value of x. So from here, to solve the length of the indicated side, let's set up a proportion involving the ratios of the corresponding sides. So we will have EF over MN is equal to EG over MP. And after that, let's substitute the value. So we will have now x over 15 is equal to 42 over 35. Again, let's apply the fundamental law of proportion. We have x times 35 is equal to 15 times 42. So we have x times 35 is 35x, and 15 times 42 is 630. So let's divide both sides, or let's apply the division property of equality by dividing both sides by 35. And let's simplify. So 35x divided by 35 is 1x or x, and 630 divided by 35 is equal to 18. So therefore, the value of x for our second example is 18. Now, let's proceed to our third example. Given the parallelogram EFGH is similar to parallelogram JKLM, solve for the value of x. So again, let's set up a proportion involving the ratios of the corresponding sides to solve for the length of the indicated side. So let's solve again. After that, let's solve by applying the fundamental rule of proportion. So from here, we're going to get the corresponding sides of line segment FG over KL is equal to line segment EH over JM. Let's substitute now the value. So the value of our FG is 12 and the value of our KL is 2x minus 6. And the value of our EH is 5. The value of our EH is 10 and the value of our JM is 5. So we have now 12 over 2x minus 6 is equal to 10 over 5. So now, let's apply the fundamental rule of proportion. So let's multiply 12 times 5 is equal to 2x minus 6 times 10. So 12 times 5 is 60, and 10 times the quantity of 2x minus 6, we have 20x minus 60. So again, let's combine similar terms by transposing the negative 60 from the right side to the left side. So it will become positive 60. So it will become 60 plus 60 is equal to 20x. So 60 plus 60 is equal to 120 is equal to 20x. Again, let's apply the division property of equality by dividing both sides by 20. So 20x divided by 20 is 1x or x, and 120 divided by 20 is equal to 6. So therefore, the answer for the value of x in our third example is 6. So in similar polygons, the scale factor determines the relationship between the measures of the proportional corresponding sides. It is very interesting to know that scale factor also determines the relationships of the other dimensions of similar polygons, such as perimeters and areas. The ratio of the perimeters of similar polygons is equal to their scale factor, while the ratio of the areas of similar polygons is equal to the square of their scale factor. Now, to understand that, let's have an example. For our example number 4, given the parallelogram CARE is similar to parallelogram HUGH, determine the scale factor and the ratio of their perimeters. So from here, given that trapezoids are similar, the scale factor can be determined by finding the ratio of any of the corresponding sides. So the perimeter of any polygon can be determined by adding all up the lengths of their sides. So from here, for our scale factor, let's get 6 and 12. So therefore, we will have 6 over 12 is equal to 1/2. For the perimeter of the smaller trapezoid, so we're going to add 6 plus 7 plus 6 plus 8 is equal to 27. That is our perimeter of our smaller trapezoid. Let's proceed now to the perimeter of our larger trapezoid. So by adding 12 plus 14 plus 12 plus 16 is equal to 54. Now, let's get the ratio of their perimeters. So by getting the ratio of their perimeters, let's get 27 and 54. So we have now 27 over 54, and the lowest term is 1/2, or 1:2. As you notice that the ratio of the perimeters of similar polygons is equal also to their scale factor, which is 1/2, or 1:2. Now, for our fifth example, in the pair of similar rectangles below, determine the scale factor and the ratio of their areas. So now, from this example, we're going to get the ratio of their areas. So again, let's get our scale factor by getting any of the corresponding sides. So for this example, let's get 18 and 21. So we will have 18 over 21, or the lowest term is 6 over 7. Now, let's proceed to the area of smaller rectangle. Again, by getting the area of a rectangle, we need to multiply the length and width. So the length and width here is 18 and 12 respectively. So 18 times 12 is equal to 216. Now, let's proceed down to the area of larger rectangle. So by multiplying again the length and width. By getting the length and width of the larger rectangle, we have 21 times 14 is equal to 294. Now, after we get the area of the smaller and larger rectangle, let's get now the ratio of their areas. So by getting the ratio of their areas, let's get 216 and 294. So we have 216 over 294 is, or in terms, if we lowest term that, we get 36 over 49, or in terms of proportion, 36 is to 49. Now, if we compare our ratio of the areas to our scale factor, if we squared our scale factor, we will have the same ratio of their areas, which is 36 over 49, from 6 squared over 7 squared. That is our example number 5. Now, let's proceed for our last example. The following pair of right triangles are similar to each other. Determine the scale factor and the ratio of their areas. Again, let's get the scale factor by getting any of their corresponding sides. So from this example, let's get 10 and 8. So we have 10 over 8, and the lowest term is 5 over 4. Now, let's get first the area of the larger triangle. Again, in finding the area of a triangle, it is equal to 1/2 times base times height. So, the base here is 50. The base in our larger triangle is 15, and the height is 10. So we will have 1/2 times 15 times 10. So 1 times 15 times 10 divided by 2, we will get 75. Now, let's proceed to the area of the smaller triangle. Again, let's apply the formula, which is 1/2 times base times height. The base of our smaller triangle is 12 and the height is 8. Let's substitute the value. We have 1/2 times 12 times 8. So 1 times 12 times 8 divided by 2, we will have 48. Now, let's proceed to the ratio of their areas. So by getting 75, which is the area of our larger triangle, and 48, which is our area of our smaller triangle. So we have 75 over 48 is, or if we find the lowest term, we have 25 over 16, or 25 is to 16. And as you notice, if we squared our scale factor, it is equal to the ratio of their areas, which is 25 over 16, came from 5 squared over 4 squared. Now, we observe from examples 5 and 6 that the ratio of the areas of similar polygons is equal to the square of their scale factor. Now, I hope you understand our lesson for today, which is similarity of figures. Thank you for watching.